Okay, so in this video I'm going to continue going through the grade 9 ASP focused questions for the end of year exam. Now we're moving over to freefall, objects thrown upwards and so on. So a few things you need to know when an object is thrown upwards, just to let you know. So this is me standing here with a ball and I throw it up and it's coming back down. A couple of things to note. You should know that the acceleration is always gravity minus 9.8. So that will tell you the acceleration is always negative, no matter where you are. At the highest point, over here, down here, same acceleration. On the way up, my v is positive on the way up. At the very top, for a brief second, it stops. V equals 0, it stops. Then it comes back down, negative, and it gets faster and faster and faster. So the higher up you go, the slower you get, and the lower down you go, the faster you get. Fun fact, the speed here is always equal to the speed here. This will be positive, maybe 5. This will be negative 5. The numbers, the values are the same. Just one's positive, one's negative. All right, keep that in mind. A ball thrown upwards, acceleration at the highest point. There you go. I don't care which point it's in. The acceleration is always negative. It doesn't matter where it is. What is the velocity and acceleration at the highest point? So the acceleration is minus. So C and D, I'm not going to look at A and B right now. We already know the acceleration should be minus 9.8, which is G. Velocity at the highest point, speed is 0, so it will be C. The velocity is 0 at the highest point. A ball is thrown vertically upwards. At what point does it experience 0 velocity and a non-zero acceleration? Fancy way of saying at the top v equals 0. Acceleration is minus 9.8. That's non-zero. It's a number. So minus 9.8 is non-zero acceleration. So that would have to be at the top, which is Q. Q is the answer. A piece of chalk is thrown vertically upwards and caught during its descent at the same height it was thrown. The position, where is there a graph? What are the signs of the position? Ascending, it doesn't matter. So basically throwing something upwards, like this idea. Upwards on the ascending basically means the going up part. Over here, I've already drawn it actually. Over here, as positive velocity is moving up, so the position will be positive. And that's all that really matters. Acceleration is always negative, isn't it? So I'm going to go for acceleration first. Well, that doesn't help. I only cancel out this one. So we know the velocity is positive. The position is also positive. The best answer is B. The position would be negative if it went down. It didn't. It actually went up. So B is the best answer here. A ball is thrown straight up from the ground. When is it 0? Already said it. 0 at the highest point. The acceleration at the highest point is the same no matter where it is. It's always negative and it's always 9.8, gravity. Let's move on to some graphs. At what time is the object 0? So this is a displacement time graph, so it's a bit like drawing the value of the curve of the actual motion. So this is here, and at the top of the displacement graph, this is when the speed will become 0, and then it'll come back down and become negative. You can see it's going down now. So this means here, at 2 seconds, it is at 0. So B is the answer there. Which of the following is true about position? Okay, so this is a position time graph about position A specifically. A is on the way up, so positive velocity, not positive acceleration. Positive velocity, negative acceleration, yes, B is correct. These two are wrong. That's for A. At B, which is the top, as you know by now, the top it would be 0 velocity. So these two are wrong. The acceleration is always gravity, always negative, always minus 9.8. So that means the answer will be D in this case. Okay, very nice. Let's move on. What about D? Over here, we're trying to see the speed, comparing the speeds of A, C, and D. As I mentioned earlier, the lower you are, the faster you'll be. Even if I'm like here, if I throw it upwards, I'm giving it an initial fast speed. Then gravity will help slow it down because gravity is always pulling down on it. So it's going to slow it down. So this is the lowest. The lowest is always the fastest. So D is the fastest, followed by A, followed by C, and then B is 0. So we have D, A, and C. So D is greater than A, greater than C. This is written the opposite way, so we have to reverse it. So we'll do C is going to be less than, C is less than A, less than D. So I've just flipped it. DAC, CAD. So that's the idea over here. CAD less than. Very good. So of course, as you know, this is less than, this is less than, and this is greater than for maths, basically. Right, grade 12, not grade 12. Question 12, where did that come from? Question 12, what are we doing? Which graph might show the velocity of a ball that's thrown straight in the air and allowed to fall freely to the ground? Thrown straight up in the air, basically going upwards, that's the starting of a positive velocity. It'll have to pass through a 0, v must be 0, and then must finish with a final velocity. This is positive 50, that's a good start. Passes through 0, finishes at minus 50. Oh yeah, well we have the answer straight away. Graph 1 is correct. This one started minus, that's wrong. This one started from 0, wrong. This one started from positive, it reached 0 but then it stopped, so that's also wrong. It has to fall freely to the ground, so it must be finishing at minus of the starting speed. Which way shall I go? Let's go right. A ball is thrown upwards. Which of the following represents the speed time graph of the ball thrown upwards? Not the velocity time graph. This was the velocity time over here. That's the velocity. It has a negative. Speed time is positive only, values only. So for a speed time graph, I will start from maybe, let's just make it up, let's say plus 50, just like the previous one. It will go down to 0, just like this one did. However, instead of going into the negative, it is a speed, it's a scalar, size only. It'll go back up to the positive 50. 50 to 50. Same thing. I just made that number up, by the way, from the previous question. C is the answer for that one. Alright, let's go down here. The velocity graph shown of this, very nice. What are we trying to see? Which is this following true statement? So, positive acceleration, wrong, gravity is minus. Moving only upwards, it's going upwards, stops at 0, and then it's going to be negative, so it must be moving downwards at one point as well. Oh, that's not a circle, that is wrong. So that is wrong. Constant acceleration, yes, it does have a constant acceleration. It didn't say whether it's positive or negative, so this is looking nice. The velocity is always negative? No, the velocity is positive here, and then it becomes negative. This is positive, that's negative, so that's wrong. C is the best answer. Constant negative acceleration is the full answer, but constant acceleration is acceptable. They didn't say whether it was negative or positive, so we can accept that answer. The child is standing on this bridge, throws a rock straight down, take upward as positive. Yeah, we normally do that, don't we? Up is usually plus, down is usually minus. That's an arrow, by the way. Okay, fine. Which graph shows the acceleration of the stone as a function of time? Acceleration of a stone. So we know it's constant acceleration and it's always negative. This acceleration is changing and it's going into the positive side, so that's wrong. This acceleration, there's 0 and it's minus and it's constant, good. If I have a constant negative acceleration, I will have a speed graph coming down. This is the speed time graph, this is the acceleration time graph of the same thing, just so you know. So that means if I had a positive acceleration, the graph will be going upwards, by the way. So this is of course wrong, and this is going to be of course wrong. It's constant acceleration, so B is the best answer over here. Very nice. Moving on to some calculations now. A rock is dropped from a height. Determine the time it takes for the rock. Okay, so this is exactly the same as the previous stuff when we did this formulas. VF equals VI equals A equals T equals and X equals. But there are some extra pieces of information. What you can know, that acceleration is always 9.8 minus. So it might not tell you that, and it probably won't tell you that, you just know it. And that means if you're throwing something upwards, the final speed at the top would be 0. If I'm dropping something, the starting speed would be 0. In this case, it's dropped. The starting speed is 0. So that's something to think about. You'll know kind of 2 of the pieces of information already without it being told to you. So keep that in mind. We have a height, 5 meters. We have everything we need. We can go ahead and actually calculate this now. Remember, we only need 3 pieces of information, like I mentioned. Let's write out the formulas quickly. What information do I have? VI, A, and X. VI, A, and X. The final speed is what I need, by the way. No, it's not. I need to find the time. I don't need the final speed. I need the time. VI, A, X, and T. VI, T, X, A. This one. Remember I said, if I don't have final speed, I can use this one. And just to remind you, if I don't have time, I can use this one. If I don't have distance, I can use this one. Currently, I don't have final speed, so I can use this one. X equals VI multiplied by T plus a half AT squared. And X I know is 5 equals, and we will do VI T, well that's just 0. 0 times anything is just 0, so don't need to worry about that. Plus a half multiplied by negative 9.8 multiplied by t, which is what I need, squared. You can rearrange, or you can do the lazy method, which is shift solve. If you're in a calculator, if you need an exam, you might want to be quick, and you can do shift solve, not make any mistakes. So let's try it. 5 alpha equals 0 plus, don't need to write it, but I did, 0 plus a half, 0.5, times negative 9.8 times t, so that's alpha x in my calculator, squared, so I must square it, squared. Shift solve 0, and see, I hated that when it does that because you've got a square here, it takes longer, and I cannot solve it. Oh, amazing, I must have made a mistake. If it fails, always go the old-fashioned way. I want to find t, so what I'm going to do is I see this is multiplying with the time, so 5 divided by 0.5 times minus 9.8. Oh, I know why, because there's a minus in the thing. That won't work. Squared. So the square root, the minuses, I have to remove the minus from this. That's why it didn't work. Anyway, I've rearranged it now anyway, and there we go. We have both learned something new. Adding the minus into a square question ruins it. So you just remove the minus. That's all you need to do. Because something squared, minus times a minus becomes a positive, FYI. 0.5 times 9.8. That was a long time spent on this question just to get the answer of 1 second. Amazing. The answer was 1 second. 1 second. There you go. So the thing to do, if you still want to do shift solve, ignore this minus. Only for the process of the question. If it says can't solve, it means you had a negative here. And it doesn't matter because it's time. Time is always positive anyway. So keep that in mind. If you're having problems with your calculator like I just did, ignore that minus. Only if it says can't solve. Okay, what's this? Flowing upwards. What is the time of flight if it reaches back to the ground? All right, fine. So there's a couple of ways I can do this one. What shall I do? Well, I have the starting speed. I know the speed at the top is going to be 0. Do I know anything else? I have the starting speed, I have 0, I have gravity, minus 9.8, perfect, that's 3 pieces of information. I can find the time it takes to get to the top, and then I can double it, times 2, because then it's going to come back down again. So let's do the first half. Let's do this bit here. Let's find the speed, or the time, to get to the top. Let's do it. Vf equals Vi equals A equals T equals, and X equals. V final, I know that's going to be 0 because that's at the top. Acceleration's minus 9.8. Don't even need to look at the question to get the numbers. Velocity, starting speed was 30. I am asked to find the time it takes to reach back, so I'm looking for time. Vf, Vi, At, that's the first equation that we're going to use, the top one. Vf, Vi, A, and T, that's this one over here. So let's go ahead and do that. I don't have displacement. Vf equals Vi plus AT, and now I'm going to write is 0 equals VI. VI is 30 plus 9.8 negative 9. Oh, I don't know, run out of space. Let's go ahead and do it. Minus 9.8 times t squared x. Okay, let's see if this works. This should work because there's no square in this, so let's give it a go. As in for the equation. 0 alpha equals 30 minus 9.8 alpha, the t is going to be my x, and that's it. Shift solve 0, and I will get my answer of 3. So that is 3 seconds to reach the top. If they wanted to be mean and evil, they could have written an option of 3.0, which means you would have selected B, but you'd been wrong. They didn't do that. So 3 to get to the top, plus 3 to get to the bottom. 3 times 2 will give me 6. 3 plus 3, because 3 up, 3 down equals 6. The time, I mean. So shift solve worked, you can just rearrange, either way. Okay, 75 kg swimmer steps off a 10 meter tower. What is the velocity on hitting the wall? Okay, well, let's do it. Vf equals Vi equals A equals T equals, what happened there? That is not right. T equals X equals. I have X already, that says 10 height. And what else do we have? Steps off, which means he started from rest. He wasn't moving at the beginning, so they stepped off, starting from 0. I need Vf. I have gravity, minus 9.8. Didn't give me the time. Which formula is without time? Let's have a look. The one without time is the middle formula. Oh god, that's got a square in there. Oh, let's see how that goes. Vf squared equals Vi squared plus 2ax. So Vf squared, well, that's just going to be 0. Ooh, okay. Plus Vi squared, Vi, oh, thank God, also 0. Plus 2, 8, what am I looking for? Oh no, I'm looking for it. That's not 0. I don't know it. What am I doing? Okay, let's do it. Plus 2 times negative 9.8 times 10. That's what I need. This is for my Vf squared. I thought I got away with it, but I didn't. All I had to do is find this and take the square root. Easy. 2 times negative 9.8 times 10 is minus 196. If you try to take the square root of that, you will not be able to do it because you're taking a square root. Vf squared equals minus 196. This is a great math discovery, by the way. Minus, that's a negative. So if I'm going to go ahead and do this, Vf squared equals minus, cancel the minus, that's all. Vf squared will cancel that minus and we'll get it. So I'll take the square root of 196 and I will get my answer of 14 would be the final answer. So Vf will be 14, but remember it's supposed to be negative. So look, we have an option here for negative 14 and that makes sense. I had to remove the minus so that I can take the square root because Vf squared is this, Vf would have to be the square root of it. So that's why I will pick minus 14 in case they give you a positive 14. Amazingly confusing question. I love it. Okay, now in this question, I've written it out here already. I've got V final, V initial, A and T. However, this is thrown downwards. My V final will be negative, acceleration is always negative. The time is 2, X is not given, so we can't use it. Vf, Vi, A and T, well that will be this formula. Vf, the first one, Vi plus AT. Vf is going to be what I need, so I'll keep it. Minus 5 plus negative 9.8 multiplied by 2. And this I'll get minus 24.6, and that means the closest answer is 25. Speed is a scalar. Scalar means I don't care if it's negative, and the closest answer is this one. I'm going to stop this video there because it's getting a little bit long. Thank you.